so today you're going to watch this video about similar polygons and similar triangles. Basically so that we can prove that triangles are similar. We're switching into a new unit here, and so this is the first unit dealing with similarity. No longer congruence, but similarity. So similar polygons are when you have polygons whose corresponding angles are congruent and whose corresponding side lengths are proportional. This is the key word right here, is that they're proportional, which means that they're not congruent, okay? There's actually a ratio between the side lengths. So one side might be twice as long as the other side. That's what it means to be proportional. And the symbol to mean similar is this little tilde symbol that you see right here, okay? So whenever you see that symbol in between two types of polygons, which are triangles, that means the shapes are similar, okay? Same shape, different sides, okay? That's what similar means. And this right here that you see is called a similarity statement, okay? So if it ever asks you to write a similarity statement, just like a congruency statement, this is what you'll write here with the similarity symbol, okay? And again, you see how the sides are proportional. Basically, you can set up a proportion to show that the sides are proportional. And when you do that, when you set up the ratio, you're finding what's known as the scale factor, okay? The scale factor is the ratio of the lengths of the sides of two similar polygons. You want to always make sure your fraction is reduced, okay? So it's asking you, what's the scale factor of ABCD to EFGH, and what is X? Well, just like the congruency statement, the similarity statement, the pieces match up. So AB goes with EF. BC goes with FG, and so on and so forth. CD goes with GH, okay? So if I wanted to figure out what the scale factor is, I would actually set up a ratio between the sides, okay? AB compared to EF, okay? Well, AB is 3, EF is 2.25, all right? And so if I wanted to figure out what exactly that fraction is, I couldn't leave it like that because that's not simplified. So I go to my calculator and I figure out that that is 4 over 3. Compare BC to FG. Let's see, well, BC is 2.6666 repeating, and then FG is 2. Well, 2.66666 repeating is the same thing as 2 2/3. 2 2/3 is the same thing as 8 over 3. Okay? So if I wanted to figure out what exactly 2.666 repeating over 2 is, I would just do 8/3 divided by 2, and I would get the fraction of 4/3. Okay? Now, these two polygons are supposed to be similar, so that means the scale factor should be the same, which I have here. And so even if I compare AD to EH, then I can see the same thing, which is, again, yes, it is 4/3. So to figure out what X is, I would need to basically set a proportion. 4/3 equals X over 4. Okay? Because I just basically take one part of this proportion that's set up here, okay? So AD and EH, I take this part right here. CD over GH equals DA over HE. Now, I picked AD and EH because these were the ones that didn't have the funky decimals in it, okay? They were just my solid numbers. So to find X, I would just cross multiply here. 4 times 4 is 16. 3 times X is 3X. And then when I divide, I'll get my answer of 5.3 repeating to be my value X. Okay? So my scale factor is 4/3. X is 5.3 repeating. If two polygons are similar, then the ratio of the perimeters is equal to the ratio of their corresponding lengths. In other words, if I were to add up all these sides for both of these two polygons, then their perimeters would have the same they would have the same ratio as their sides would, okay? So if I were to add up all the sides here, 3, 4, 2, 11.25, I will get 11.25. That is my perimeter. Okay? Over here, this is where I have the continuous decimal, so I'm going to revert them back to fractions. So 2.6 repeating is 8/3, and x, my 5.333 repeating, is the same thing as 16/3. All right? So when I add all those sides up, 4, 3, 8/3, 16/3, I get 15, a perimeter of 15. So if I were to compare their ratios 15 over 11.25, and I were to divide them, I should get the same thing, which I do. Okay? Now I get this answer by, again, just typing it into my calculator. And if you're wondering where I got 4/3 from, because I know you're probably getting 1.33333 repeating in your calculator, well, it's basically 1 and 1/3. 1 and 1/3 is the same thing as 4/3. Remember, you multiply the big number by the denominator and then you add the numerator. Remember, converting from proper fractions to improper fractions, that's where you get that from. Now, there are some postulates and some theorems that will help you determine whether triangles are similar. The first one is AA, angle-angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, then you know the two triangles are similar. Okay? Take a look at the very first example. Explain why these two triangles are similar. These should be triangle symbols here. You know my program doesn't convert these to triangles. Well, I know that angle WBX and angle WZY, they're both right angles. And since they are right angles, I know that they're congruent to each other because all right angles are congruent. I also have another angle that's congruent, which is angle W. Angle W in the small triangle is congruent to the same angle W in the big triangle. Do you see how I just split those two up right there? Okay, and because they have the same angle, angle W by reflexive property should look familiar, then that's why my two triangles are similar by angle-angle similarity. Okay, make sure you just put the similarity symbol to distinguish between regular congruency and similarity. Down here, these two triangles are similar as well because you see the symbol right here. That means parallel. That means that angle TEC is congruent to angle TBW, and angle TCE is congruent to TWB, because those are corresponding angles. So yes, these two triangles are similar by angle-angle similarity, and my similarity statement will be triangle TEC is similar to triangle TBW. The same way I would write a congruency statement is the same way I would write a similarity statement. At any point in time, you need to pause it, rewatch something, please do so. The last two are both theorems, side-side-side similarity and side-angle-side similarity. Exactly what you think, but a little bit different from what we know of congruent triangles. Side-side-side similarity basically says that if the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So no longer are the sides congruent, but they're proportional. That's how you can prove that the triangles are similar by side-side-side. Now, side-angle-side similarity is very similar again. It says if an angle of one triangle is congruent to the angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So kind of what side-angle-side congruency theorem was, where basically you have two congruent sides and a congruent angle in between. Same concept, except this time the sides are not congruent, they're proportional. And then the angle is congruent, that's in between them, okay? Now, by proportional, so say in this example, this side was 3, this side was 6, this side was 4, this side was 8, this side was 10, this side was 20, okay? You see the ratio between the sides is 1/2, because 3/6 is 1/2, 4/8 is 1/2, and then 10/20 is 1/2. That would be the size proportion. This will be an example of side similarity. Say I'll put an angle in between them, such as 6 degrees. The angle would have to be congruent. The sides are still proportional, and now the angles are congruent. Okay? So what I want you guys to do is I want you to try some of these problems, okay? And then after you try some of these problems, I want you to watch the second video that actually goes through each one of these problems, okay? If you have any questions, you can always send me a message through My Big Campus, or you can bring your questions to class tomorrow.